examples of relations. So I am writing one question. Or it is the example 3 of NCERT. So let me write example 3. So here we can see that it is written. I will write it first. So the question is like this: let capital L be the set of all lines. Let capital L be the set of all lines. In a plane. And capital R is the relation in L. Be the relation. Then definitely capital R will be a subset of L cross L. L cross L will contain all the possible relation of the set
Yes.
L.
L cross L.
Yeah, L cross L. Because it will contain all the set of ordered pairs. So it is the set of all the possible relations, and capital R will be a subset of that. Capital R will be a special relation which will be following the property, and that property we will discuss.
Okay.
The property is defined as capital R, which is the relation. It is equal to, it will contain only those ordered pairs such that those two lines are perpendicular to each other. L1 is perpendicular to L2. Because see, we know now the set L, it contains all the possible lines. And relation R will contain only those ordered pair in which L1 is perpendicular to L2.
Okay.
Okay, this is the relation. Now we have to show that R is symmetric, but neither reflexive nor transitive. Yeah. So show that.
Means it is not A, comma A.
Yeah.
Yeah. And transitive.
R is symmetric. But neither reflexive not transitive. This is the question. So let us try to do this. So if we look into the reflexivity, so definitely see, in order for the relation to be reflexive, a line should be perpendicular to itself, which is not possible. Any line cannot be perpendicular to itself. Like if it is a line, it cannot be perpendicular to itself.
Yes.
And hence, A comma A, that property will never be applicable for this
Table, yeah.
relation.
Yes. Okay.
So we can write like this. Because in the exam, na, presentation matters a lot.
Uh-huh.
So we can write since a line L1 or let me be more precise. Yeah. Since a line cannot be perpendicular to itself, since a line cannot be perpendicular to itself, so I can write so for all small l belonging to L comma L does not belong to capital L. I can say that hence R is not reflexive.
Yes.
So this mathematical the terminology which I have used, let me know if you have any problem in understanding this mathematical terminology.
Okay. Abhi, I understand like L belongs to
Yeah,
capital
right.
L, the set
Yeah,
element. Yeah.
yeah. So small l is the element. So for all
Yeah.
small l belonging to the set capital L, which is the set of lines. Yeah, now you tell. So that is right. Then the ordered pair L comma L does not belongs to R because we have given the reason for that. Since a line cannot be perpendicular to itself, any line cannot be perpendicular to itself. That's why L comma L will not belong to R, and hence R is not reflexive. Now symmetricity we can check. Yeah, that is easy to understand.
Hmm.
That if L1 is, or first I have to write like this mathematically. First I have to write like this for L1 comma L2 belonging to set L. Then I have to write like this. If L1 is perpendicular to L2, if L1 is, because if any line L1 is perpendicular to L2, then definitely L2 will be perpendicular to L1.
Yes. So it is symmetrical.
It is symmetrical. So if L1 is perpendicular to L2, then L2 will be perpendicular to L1. L2 will be perpendicular so we can say that that is if L1 comma L2 belongs to R, then L2 comma L1 will belong to R. And we can say hence
We have to show that it is not transitive also.
Yeah, R is symmetric. Yeah, we can show that.
Mm.
So for transitive, we can take 3 lines. We can take 3 lines for L1, comma L2, comma L3 belong to set L. Now, if L1 is perpendicular to L2, if L1 is perpendicular to L2 and L2 is perpendicular to L3, does not imply L1 is perpendicular to L3, and we will prove it with a diagram. One figure we will draw. L1 is does not imply L1 is perpendicular to L. So let us suppose I have a line L1 and I have a line L2 which is perpendicular to L1, and I have a line L3 which is perpendicular to L2. So L3 has to be something like this. And we can very clearly see that like this is L1, this is
Aren't L3 and L1 perpendicular to L2? In
yeah, yeah, that
yeah.
is right. See, L1 is perpendicular to L2, L3 is perpendicular to L2. That is right. But for transitivity, L1 and L3 should also be perpendicular to each other. But that cannot happen because
Yeah.
in the diagram we can see that L1 and L3 they are parallel to each other. So
Yeah.
mathematically, I can say that is if L1 comma L2 belongs to R, it means L1 and L2 are perpendicular to each other, comma L2 comma L3 belongs to R. Like L2 and L3 are perpendicular to each other. Then L1 comma L3 does not belong to R because L1 and L3 can never be perpendicular. And if they are not perpendicular, this relation, this ordered pair has no place in R, in set R, because set R will uh, only contain those ordered pairs which are perpendicular to each other,
Yeah.
and hence transitivity is not followed. Hence, R is not transitive. Okay, is it clear?
Okay. Yes.
Let us do like this. We will do lots of practice so that we become very comfortable in all the topics.
Okay.
Example 4 also. so that relation R three comma 1 comma 2 2 comma, so that relation R in set in the set 1 2 3. So the set is 1 2 3. Is reflexive but neither symmetric nor transitive. Transitive. Okay. So this is what we have to do. So let us do this. So we can check all the conditions one by one.
Yes.
So first, the reflexive. So for reflexive, I can write its definition to get good marks. For all A belongs to capital set A comma A belongs to R on set A. Then R is reflexive. Now here we can show that we can give example here. One comma one, or we can show that here for small a is equal to 1 comma 2 comma 3, 1 comma 1 belongs to R, 2 comma 2 belongs to R, and 3 comma 3 belongs.
Yes, so it is reflexive.
So it is reflexive. R is symmetric. So first, let us try to analyze it. Then we can write it properly. So for symmetric, if 1 comma 2 is there, So 2, 1 we should have.
Yes, which is
But
not there.
which
2,
is
1
not
is
there,
not there.
and
Yes.
hence it is not symmetric. If
And same for transitive also.
the okay, tell me how.
1, 2 is there, 2, 3 is there, but 1, 3 is not there.
One is that
So it is not transitive and
it is
symmetric.
it is
Yeah.
not transitive. That
Yes.
so the answer to you got it right.
Yes, yes.
Yeah, I am just now writing symmetric. And if the question is like carrying only 1 mark or 2 mark, like
Yeah.
1 mark, then so you can just directly write the answer. And
Yes.
if it is reflexive, just show that okay, all these things. If it is not symmetric, you write not symmetric, but also give an explanation why. So you tell that here uh,
Yeah.
1, 2 belongs to R and 2, 3 belongs to R. No, sorry, yeah. Okay, why it is not symmetric? Okay, 1, 2 belongs to R, but
2, 1 is not there. 2, 1 does not belong.
2, 1 does not belong. Similarly, 2, 3 belongs to R,
But 3, 2 doesn't.
3, 2 does. And hence you will say that R is not symmetric. Hmm. Transitive. We can give an example why it is not transitive.
Mhm.
So here 1, 2 belongs to R and 2, 3 belongs to R. But
1, 3 does not belong to R.
and hence it is not transitive.
Yes.
R is not transitive. Now we can do one more question.
Fifth.
Example number 5.
Yes.
Fifth example. So we have a relation R on relation R in the set Z. That is the integer relation. So we have R. Let me write it properly. I will write relation R. Relation R in the set in the set capital Z of integers. Relation R in the set Z of integers.
Okay.
And relation R is given something like this.
Mission Ash.
Is equal to A to B, like ordered pair. And what is the relation, the property? 2 divides A minus B. So the idea is that, see, set of integer is a very big set. Like
Yeah.
it contains infinite, minus infinite to plus infinite numbers. Now the idea is that R will contain only those ordered pair whose difference is an even number. 2 divides A minus B means A minus B should be divisible by 2. It means A minus B should be even.
Yes. 2 divides, right? Yeah.
Yeah, 2 divides A minus B. It means that whatever ordered pair we are taking, the difference of that, those two numbers should be even. This is the relation. Now, what we have to do in this question? Test
Or
for equivalence. Yeah, tell.
like 5 minus 3, which will give 2.
Mhm.
Is that possible?
Yeah, because 2 divides 2, that is possible. 2 ones are 2.
Yeah.
Yeah, that's possible. Any number which can be divided by 2. Like 2 divides A minus B. So if A minus B is 10, then 2 divides 10. 2 can divide 10. 2 can divide 20. 2 can divide
So
14.
how do we approach this question? Like, what do
Yeah,
we have to start by?
very nice. So see, now the idea is that regardless of whatever they ask, they are like whatever relation they have given, we can
Yes.
get to there after some time. First, that they are asking us to test the equivalence, check whether the relation is equivalent or not, or they will tell us so that this relation is equivalence. So we have to do one property at a time. Like first we will start with the reflexive. We will test for reflexive. So I will write reflexive. And you can write the definition of the reflexive for all A belongs to set Z, and or here I can write definition. I'm writing a general definition for reflexive. For all A belongs to set A, and A comma A belongs to. This is the general definition. Now what we have to do, we have to check whether A minus A here for all A belongs to set of integer, we have to check A minus A, that is 0. And we know that 0 is divisible by all the numbers. All the numbers can divide 0. So A minus A, which is equal to 0, is divisible by 2. Then I can write Hence, A comma A belongs. Now try to understand it and let me know if you are facing difficulty in understanding this. What I have to.
Uh, that okay.
Mhm.
The 0 is divisible by 2. So
Yeah.
A comma A belongs to R.
Because the definition of the relation itself it says that A comma B should be divisible by 2, like A minus B. Then I will say that A comma B belongs to R. And
Okay.
if A minus A is divisible by 2, then I can say that A comma A will belong to. And
Okay.
hence I can say that R is reflexive.
But
I think
how
it,
is 0
yeah,
divisible by 2?
yeah, yeah. Good question. Very good.
Hmm.
It's a very interesting question that why 0 can divide, like 0 is divisible by all the numbers. Why is it so? Let us prove it. Let us prove it. Let us prove. See, what is the concept of divisibility? The concept of divisibility is that we say that a number is divisible when the remainder is 0. So what is the divisibility test? Remainder should be 0. You know the remainder, what it is.
Okay, okay, I understand now.
Yeah,
Yeah.
yeah. So
So upon 0. So it is divisible only.
remainder should be 0. Now let us suppose I have 0 as the number and let me divide 0 with different numbers. First, let me try to divide it with 2 as in our question. 2 zeros are 0. And what is the remainder? 0. Since remainder is 0, I can say that 0 is divisible by 2. Let us take one more example wherein we have 0 and we will divide it with any number like 10.
Just
10.
give me 1 minute. I'm just coming. I'm getting a lot of cold.
Okay,
Just
okay. Please, please. Take your time.
Yes, I'm back.
Yeah.
Ah, ये सबसे पहले नाक सुर कर रही थी. So I just cleaned it.
Yeah.
Yeah.
So
Okay, so I understood the divisibility part. For some reason, by mistake, I thought it meant 0.2. That's why.
yeah, it is 0.2 only.
0.2? No, wait, I can't draw on the whiteboard right now. Some setting. But I thought it's 2 upon 0.
Okay, wait, let me check for that.
Okay. Yeah.
I think you can draw.
Mm.
Okay. Ah,
Kya?
yeah, you did something and it changed
What changed?
the whiteboard. Try writing something. Okay, you're not able to write.
View only option में maybe.
Acha.
Wait, let me see.
Oh, yeah,
This is something else.
yeah, you can write this.
I think this is a timer thing. Okay,
No,
okay.
this the whatever you have written now. Acha, that is getting vanished.
Okay, anyway, so I thought that I thought it meant this. Look, is it कौन सा है इसमें?
Yeah, so 0/2. See, 2/0 is impossible. 2/0 is not defined.
Okay.
2/0 is not defined. In the denominator, if we get 0, that is not defined.
Yes. Okay.
Isn't it?
Yeah. You're
Always,
right. Somewhere
always,
also. So I
yeah.
when I'll come back to this note, I'll remember this thing.
Yeah. No, next
Exactly.
time I will take care. Like when I share the whiteboard, there is an option. I will make you the editor so that you can write along with me.
Yeah, for now I can only write for 5 seconds and then it vanishes.
Yeah.
Yeah. Okay. So
Yeah.
ठीक है. So this is reflexive
Right.
because yeah.
Because A comma A belongs to R.
Yeah.
Why?
Now we have to.
Yeah. Why
Hmm.
A comma A belongs to R? Because A minus A is 0 and 0
Which
is
is
divisible by 2.
0. Yeah.
And hence it is satisfying the property.
Yes.
Now we have to check the symmetric. For symmetric, the definition is for all A comma B belongs to A and if A comma B belongs to R implies B comma A belongs to. It is symmetric. Now let us check this for our function. Yeah. So here for all A comma B belongs to Z, like integer, if A minus B is divisible by 2, if A minus B is divisible by 2, then B minus A will also be divisible by 2. And you can cross check it. You can take some examples, like no need to write examples here, but for your understanding, you can like we can try that. B minus A is
Yeah.
divisible. Because if we interchange the number in the taking the difference, sign might change. And it's okay. If the number become negative, then also it's fine. If as long as it is divisible by 2, I'm okay with that.
Right.
So either I do A minus B or B minus A. If A minus B is an even number, or if it is divisible by 2, then B minus A will be an even number. It will be divisible by 2. Hence, A comma B belongs to R implies B comma A belongs to and I can say R is symmetric.
We can't take 2 minus 3 for this. Or 3 minus 2.
Yeah. 3, 2 we can't take, na?
Yeah.
But 4, 2 you can take, 4 comma 2.
Yes.
So either of the way, 4 minus 2 you do or 2 minus 4 you do.
Yes.
Either of the both, it is divisible by 2.
Yes. We have proved that this is reflexive, symmetric, and now transitive.
Transit. So the definition, mathematical definition of transitive for all A comma B comma C belongs to any set A, and if A comma B belongs to a relation R and B comma C belongs to relation R, then A comma C should belong to R in order for the relation to be transitive. So let us try to apply this definition for this context here. For like, let us take any 3 integers for all A comma B comma C belong to Z. If first 2 integers like A and B, like A minus B is divisible by 2.
Okay. No, then B minus C should also be divisible by 2.
And
A minus C.
B minus C is also divisible by, let us, we are assuming it. And
Yeah.
B minus C is divisible by 2. If it happens, then what we can say about A minus C? Let us see.
This is the last question that we're doing now, right now. So
Yeah.
I think I might have to go somewhere after we complete this question. So then when can we do the class?
Yeah. So we will discuss that. And like right now, we are live. Let us complete this question, then we will discuss.
Acha, okay, you can tell me
Yeah.
accordingly then. Okay.
Yeah,
Okay.
yeah.
Finish this then.
Yeah. Just 2 minutes. So A Now see, the idea is that if a
A
minus
minus-
b
Yes,
is
then B
divisible by 2,
minus C is also divisible by 2 and A minus C is also.
we will prove that. See, if
Okay.
a minus b is divisible by 2, what I can do? I can write it in this form. A minus b divisible by 2, it means a is an even number. A minus b is an even number. Even number means 2L. I can write like this. Like 2 into some constant. And b minus c is also any even number. I can write it 2M. Now, if I add both, what I will get? A minus b plus b minus c is equals to 2L plus 2M. So a minus c, what I will get? A minus c, I will get 2, I can take outside L plus M. And this L plus M, I can write a new constant, which is having 2 into something. It means that A minus C is even. I have proved it. And if A minus C is even, I can say that A minus C is divisible.
Wait,
Yeah, take it. That's,
what does this mean?
see, yeah. You got now how we got this.
Yeah. But A minus C,
Yeah. So see, 2 into anything will have, it has to be divisible by 2. Because this L plus M can be any number. I am not interested at all. But this 2 will make it divisible, because whenever I will divide this number by 2, this 2 will cancel out.
okay.
So A minus B will always be divisible by 2, regardless of whatever this L plus M is. L plus M can be any random number. Let
Okay.
it be. Let it be any random number. Because of this 2, A minus C will be always divisible by 2, because always there is a scope to cut 2. And
Okay.
hence we will say that it's divisible by 2. And
Okay.
like two things, like one line I will write. Hence A comma B belongs to R. B comma C belongs to R, implies A comma C belongs. And hence I can say that R is transitive.
So to show that A minus C was divisible by 2,
Yeah.
but then I'm not able to get the relation.
अच्छा अच्छा फिर से let us understand. See, A minus B is divisible by 2. It
Yes.
means that A minus B is equal to 2 into any number. Like
A minus means,
it means, see, if A minus B is divisible by 2, it means that A minus B is a multiple of 2.
okay.
See, if A minus B is divisible by 2, it means that A minus B is an even number. Any even number you take, it is divisible by 2.
Yes.
And all the even numbers, they are multiple of 2.
Yeah.
So
So
I can
any
write
number into 2.
any number into 2.
Okay. So we did the same for A minus B and B minus C. Okay, I got it. And then we added these equations.
Then
To
minus
show-
B plus B will cancel.
To show that any number multiplied by 2 is also equal to A minus C.
Yeah, when you will add these two numbers, this will cancel.
Okay, I got down.
And we showed that A minus B is also a multiple of 2, because of which A minus C is even, because of which I can say that A minus C is divisible by 2.
Yes. Okay. And now it is an equivalence. All are proven.
Yeah, since we have